Alright, so first lesson of chapter 5, we're going to be doing some polynomial stuff, and this day especially, like the next couple days, I think will feel like kind of a welcome relief after chapter 4. This is all exponent stuff, you know, simplifying x squared times x cubed or something like that. So operations with polynomials is what we're doing all day today. Poly means many, and so polynomials have many terms. We're going to start with monomials, and the prefix mono means one. And so we're starting off with just these one-term expressions and how to simplify them. And so we've got all of these properties of exponents. We've got, let's see, 1, 2, 3, 4, 5, 6, 7 of them. So we're going to write them down, kind of talk about it, maybe give an example or two. So the product of powers. Here's our first example. If we take a base x raised to a power a and then multiply it by a base x raised to a different power b, what you do to simplify that up is you add the powers. So the new answer would be that base x, and then our new power would be a plus b. And as an example, let's say we had, just like I said, x squared times x cubed. Remember what this really is x times x. And what this really is x times x times x. And so altogether we end up with 5 copies, x to the 5th, which I could have gotten from adding the 2 and the 3, and I would get 5. So that's how that first property works. Next one, the quotient of powers. If I have a base to a power divided by the same base to a different power, the rule tells me that I subtract those powers. So my new power will be the numerator's power, a, minus the denominator's power, b. Okay, so again, an example. Let's say I have x to the 5th divided by x, which is technically x to the 1st. So remember, x to the 5th is 5 copies, and then x to the 1st, of course, is just 1 copy. So as you're simplifying, what you could do is cancel these guys out. And so you've got 4 copies left, which would be x to the 4th, or you could have subtracted 5 minus 1 to get 4. A negative exponent. If you have a base x raised to a negative power a, what you do with that negative power is you flip it down to the denominator. So then it would be a positive a down in the denominator. If for some reason you had a negative exponent in the denominator, you would flip it up to the numerator as well. Alright, so say for some reason we had like a b to the negative 7th, we'd write it as 1 over b to the positive 7th. So that's just one to kind of memorize. I can't display it as well as I can display these ones for you, but a negative exponent means it belongs in the denominator. Power of a power. So let's say I have a base x raised to a power a, and I raise that entire quantity to a power b. What I do is I multiply those values together. So my new power will be a times b. Okay, so I can give you an example for that as well. We'll keep nice, easy numbers. Let's say I have x squared and I cube it. Okay, so anything cubed means I multiply it by itself 3 times. So that's x squared times x squared times x squared, which means it's x times x times x times x times x times x, which is 6 copies altogether. 6 is 2 times 3. So I could have multiplied the 2 times 3 and gotten my new power. The power of a product. Okay, so say I have 2 variables, x and y, and then I want to raise it to a variable a. What I do with that is this is x times y times itself however many times. What ends up happening is I get x a times, and I get y a times. Okay, so let's look at something like 2x to the 3rd. Remember, raising something to the 3rd really means I'm multiplying it by itself 3 times. And so when I kind of multiply like terms together, I multiply 2 times 2 times 2, which gives me 8, and I multiply x times x times x, which gives me x cubed. So I could have just raised 2 to the 3rd power, 2 cubed is 8, and then raise x to the 3rd power, which will give me x cubed. Power of a quotient, very similar to this one. If I have a quotient, x over y, and I raise it to a power a. We've already kind of seen this one a little bit with fractions. What you can do is you raise the numerator to that power, and then you raise the denominator to that power. Okay, so example, let's use a fraction for this one actually. Let's say we have like 2/5 or something like that, and you want to square it. You know that means we're multiplying 2/5 times 2/5. So 2 times 2 gives us 4. 5 times 5 gives us 25. So it's basically like I squared the 2, and then I squared the 5. It's like distributing that power to the numerator and denominator. Okay, and our last one here, the 0 power. If you have any base and you raise it to the 0 power, what you get is 1. All right, so anything raised to the 0 power is 1. So say you take, the number 6 and you raise it to the 0 power. That actually just gives you 1. Okay, so those are all our rules. Keep those handy as we're trying to simplify things down. So quick definition, recall a monomial. A monomial is a number, a variable, or an expression. So let's just say an expression. So it could just be a single number like 2. It could just be a single variable like x, but it could be a whole expression. That is the product of one or more variables with non-negative integer exponents. Okay, so what we're going to do is we're going to start simplifying monomials. And if you look down to the bottom of the page for an example, these guys right here, we are trying to turn them into monomials. They're very similar to monomials because this is like one expression. The only problem is it has some negative exponents, so it doesn't fit quite with this. Okay, so simplifying monomials is what we're going to work on. So there is a 4-part criteria to make sure that monomials are actually simplified. All right, so let's write these down really quickly. So a monomial expression is in simplified form when there are no powers of powers, okay, so you can't have powers of powers like you have in this expression up above. No powers of powers. Each base appears exactly once. So in a lot of those properties up above, the x appears more than once, but once you simplify it using the properties, it only appears once. All fractions are in simplest form. And there are no negative exponents. No negative exponents. All right, so those are our 4 rules. Okay, so for some reason I didn't realize it, but my iPad cut me off while I was recording. So I've already got this written down, but I'm just going to walk you through it. So what I'm doing is I'm multiplying these 2 expressions together, and so I have this 2 times negative 7, and that's where I get the negative 14, and then I'm multiplying out like terms, and so I wrote these out once for you. So the x to the negative 3rd times x to the 5th, I wrote that right here. Y to the 3rd times y to the negative 6th, I wrote that right here. And then I'm going to use this property right here that tells me if I have a base times a base, I add their powers together. Okay, so I added the negative 3 plus positive 5, and I get a power of positive 2. And then I added the 3 and the negative 6, and I got a power of negative 3. Okay, last step, and my last rule right here is that I can't have negative exponents. So this rule right here tells me if I have a negative exponent, I flip it down into the denominator and make it positive. So that's what I did here. This y to the negative 3rd, I flipped it down to the denominator where my power is a positive 3. All right, so that is simplified form. Let's flip. Okay, a couple more examples here. So we are going to simplify all these numbers down. So first of all, we have 15 divided by a negative 3. That gives me a negative 5. I have c to the 5th in the numerator, c squared in the denominator. Remember what I do is I subtract those exponents. So on the c, I'll have 5 minus 2, which is 3. For d, I subtract 3 minus 7, and my new power will be negative 4, which is 3 minus 7. Okay, so last thing I need to simplify, I'm not allowed to have negative exponents. So I'm going to take that d to the 4th and flip it down into the denominator. And so the 4 will be positive down there. So that's simplified. One thing I needed to do here was simplify my fractions. That was one of my rules. Okay, here What I'm going to do with this one is I'm going to follow that quotient rule where I distribute the power to both things. So I will raise that to the negative third, and then 4, I will raise that to the negative third. Both of them are negative exponents, so I'm actually going to have them trade places. Like the a to the negative third, I need to write it as a to the positive third in the denominator, and then 4 to the negative third, I need to flip it up and write 4 to the positive third. Now, last thing is I don't ever write 4 to the third. I need to figure out what 4 times 4 times 4 is. And 4 times 4 times 4 is 64. And then over a to the third. So that is my simplified monomial. One more of these. Here I have this fifth power, and I'm going to raise everything to the fifth power. So negative 2 will get raised to the fifth power. X to the third will get raised to the fifth power. And then y squared will get raised to the fifth power. So when I have a monomial like this, I can distribute the fifth power to every term. So negative 2 to the fifth power. This is negative 2 times negative 2 times negative 2 times negative 2 times negative 2. If you were to plug that into your calculator, what you get is a negative 32. Okay, so we have negative 2 and 4, negative 8, positive 16, negative 32, when you keep multiplying by copies of negative 2. This one, I haven't seen this rule yet. When I raise a power to a power, what I do is I multiply them, because this is really x cubed 5 times. X cubed, x cubed, x cubed, x cubed, x cubed, which ends up being x to the 15th power when I multiply 3 times 5. And then same thing here, this is y squared 5 times. So altogether, I will have 2 times 5, which is 10 copies of y. Okay, so now polynomials, full polynomials with just more than one term. So operations with polynomials. First definition, the degree of a polynomial is the degree of the monomial with greatest degree. Oops, greatest, that's a G. Okay, it's the degree of the monomial with the greatest degree, and the degree is like the power. We'll kind of walk it through with this. Okay, so determine whether each expression is a polynomial. If it is a polynomial, state the degree. So there are a handful of rules that we need to talk about here. They actually are things that we already talked about, whether something is a polynomial or not. So one of the rules for a polynomial is that you're not allowed to have anything in the denominator. I don't know if you guys remember this from a previous chapter, but this one, x over y is not a monomial. A polynomial is just the addition or subtraction of a bunch of different monomials together. So this guy right here, x over y, is not a monomial. If it were a monomial, I wouldn't have anything in the denominator. So no, this thing is not a polynomial. And that's because you can't have variables in the denominator in a polynomial. Okay, next one. Let's see. All of my powers are whole numbers. I don't have any denominators. Okay, so this one is a polynomial. So this one we get a yes. We cannot have anything in the denominator like that. You can't have square roots or anything like that either. So this, we look for the largest degree. This one, we add the degrees together. 5 plus 1. This one has a degree of 6. Here, 4 plus 7. Or I'm sorry, 4 plus 3 is 7, and then here 1 plus 1 is 2. So this one right here has the largest power when I add those powers together, and so the degree of the polynomial would be 7, because when I add the 4 and 3 together, I get 7. Okay, this example we are going to simplify polynomial expressions. So you simplify polynomials just like you simplify monomials. Okay, so whatever operations we've got, so like this one we're subtracting, so we subtract everything and then combine up like terms. Okay, so here we've got a negative x squared minus x squared. So I'm going to write out all the steps once. Here's a negative x squared, and then minus this x squared. Then over here I have a negative 3x minus positive 2x. Oops. Back over here I have a positive 4, and then minus 5. So combine up all of our like terms. These two are both x squared, so I combine up the coefficients. Negative 1 gives me negative 2x squared. Here I have a negative 3x and a negative 2x. When I combine up the coefficients, I get a negative 5. And then I add these two together. Positive 4 and negative 5 gives me a negative 1. So that's all I'm doing for that. It's basically just subtracting and then combining like terms. Okay, another one right here where I combine up all my like terms. So here I have 3x squared, and then plus, well, there's no x squared term over here. All right, so plus nothing, but then I do move over to the x term, so plus a negative x. Then back over here it's the constant, negative 6 plus this positive 1. Okay, so there's really only one set of like terms to combine up. I have my 3x squared, it didn't combine with anything. I have a negative x, it didn't combine with anything. And then I have negative 6 and a positive 1, gives me a negative 5. Alright, so that's my final answer with that one. Do I have one more? No, I don't. Okay, so here's this one. First question. Is the set of polynomials closed under addition or subtraction? With this means if something is closed under an operation, that means if I add two polynomials together, I still get a polynomial. Or if I subtract two polynomials, I still get a polynomial. And so if we look back here, I subtracted two polynomials, and yeah, I still got a polynomial. And here, I added two polynomials, and again, yes, I still got a polynomial. So yes, the set of polynomials is closed under addition and subtraction. Okay, so because adding or subtracting results in still getting a polynomial, yes, the set of polynomials is closed under addition and subtraction. Okay, if you add polynomials, you still get a polynomial. If you subtract polynomials, you still get a polynomial. Okay, so now we're going to move on to multiplication. We did addition and subtraction. We'll now do multiplication. Okay, so these ones right here, very similar to the distributive property. I've got this monomial on the outside, and I'm going to distribute it to all of my terms, and then see what I get. Okay, so this one, I'm kind of write out all the steps for you for the first one. So I'm going to take 4 thirds x squared, and then multiply it by the 6x squared, and then plus 4 thirds x squared, distribute it to the 9x, then plus 4 thirds x cubed, distribute it to the negative 12. Okay, so for this one, just because it's our first one in a while, I'm going to write all the work out for you. So we multiply the terms together. 4 thirds times 6. This is a really easy trick to multiply with fractions. 1/3 of 6 is 2, so 4 thirds of 6 would be 8. 2 times 4. So we get 8, and then x squared times x squared. I add the exponents, and I get x to the 4th. Plus, next one, 4 thirds of 9. Again, 1/3 of 9 is 3. So 4 thirds of 9 would be 12. And then I add these exponents. X squared times another copy of x gives me x cubed. And then here, this is a negative, so minus 4 thirds times 12. Well, 1/3 of 12 is 4, so 4 thirds is 16. And then I still have my x squared. Alright, so that is my new polynomial. Okay, and one more here. Okay, so negative 2a, we distribute here. Negative 2 times negative 3 gives me 6, and then a times a squared gives me a cubed. Distribute to this next term. Negative 2 times negative 11 gives me positive 22, and then a times a gives me a squared. And last one, negative 2a times positive 20. Negative 2 times positive 20 gives me negative 40, and then don't forget my a. Okay, so new expression there. Alright, this next one right here. Let's see if we want to use this. Yeah, we can do this. Paul has $900 to invest in a savings account that has an annual interest rate of 1.8% and a money market account that pays 4.2% each year. Write a polynomial for the interest he will earn in 1 year if he invests X dollars in the savings account. Alright, so this one right here, he is investing, let's see, $900 in the savings account. So $900 in the savings account, and he gets 1.8% interest. That's 0.018 that he's making off that. And then a money market that it pays 4.2% each year. Alright, so that, hold on, that is a little bit mixed up. Invest in a savings account. That did not give us enough information to solve that. That is not enough information at all. Yeah, you know what, we're going to skip it anyways because I want to get you guys through these things. Okay, number 6, find each product. Okay, so this one is like foiling on steroids, right? It's like super foiling. So what we do when we multiply the polynomials together like this is we are going to take each one of these terms. You know how FOIL works? Like we take the first, then the outside, then the inside. The way that these work is I take each every single one of these terms, like I start with the x, and I multiply the x squared times both of these terms. Then I move to the 4x, and I multiply the 4x times both of these terms. So for this first one, I'm going to write out all the work. Okay, so first I start with this x squared, and I multiply it by the x. Okay, and now I'm still on this x squared, and I multiply it by the negative 4. Okay, so I distributed the x squared to both of these things. Then I moved to the 4x. So positive 4x times this x, then a positive 4x times the negative 4. Okay, then I move to the 16. So positive 16 times x, and then 16 times negative 4. Okay, so I took this trinomial and I distributed it to this binomial right here. Now I'm going to simplify up. So x squared times x gives me x cubed. X squared times negative 4 gives me a negative 4x squared. 4x times x gives me a 4x squared. 4x times negative 4 gives me a negative 16x. 16 times x gives me a 16x. And then 16 times negative 4 gives me a negative 64. So if you're looking at some of these terms, when we combine these up, there's only one x cubed, so I just write that. These guys cancel each other out because I have one positive, one negative. And these guys also cancel each other out. And all I have is this negative 64. So when I multiply these crazy things out, it actually simplified up quite a bit. All right, I'm going to do that again. I'm going to write out less work with this one, though. So I'm going to start with the 2x squared. So first I distribute it to the 3x. So 2x squared times 3x, I get 6x cubed. Okay, then distribute to the negative 1. And I get negative 2x squared. Okay, then move to my next term, the negative 4x. Negative 4x times 3x gives me negative 12x squared. Negative 4x times negative 1 gives me positive 4x. Okay, then I'm going to move to my last term, this 5. 5 times 3x gives me 15x. And then 5 times negative 1 gives me negative 5. So all that I have left to do is combine up my like terms. So for x cubed, there's just this 6x cubed. And then I have these two terms for my x squared. Negative 2 and negative 12 gives me negative 14x squared. Then these two terms, positive 4 and positive 15, and I get positive 19x, and then minus 5. Okay, so that is my new polynomial. So are polynomials closed under multiplication? Meaning, if I multiply two polynomials together, do I get a new polynomial? And the answer is, again, definitely yes. All of these things that I got when I was multiplying my polynomials together ended up to still be polynomials for sure. Okay, oh, that's the end.